This is a cone application, and I'm going to go ahead and let Masterson kind of explain what's going on here and what we've done here to provide material flow.
Well, this shows a typical cone section, and it can be many different materials. I think it was an iron ore bend for a cement plant. But it shows how many things we've tried to finally get to where we had a solution. Sometimes we call it the Band-Aid fix. How many things did we try to do? But the final solution here was 3 air cannons, basically in a ascending spiral pattern. So as you can see at the end of the cone where the discharge is, that's basically like a bottleneck. We need a tension there. If the material starts to bridge on the lower part of the cone, we've got a couple of cannons to knock that out. And typically this was having a problem on the very lower third of the cone section. But the customer had tried the electromagnetic vibration. It had tried hammer rash, Cardox ports, aeration lines above the cannons, and poke hole doors. So they are poke hole ports there. So anyway, the main deal was setting the cannons there in the right place, automating the system, and firing it when they need to, knocking out the bridging material, and now we have production on a reliable basis.
Perfect. This particular application, like Masterson said, you have different types of flow aids. Initially, where the last right of refusal was the air cannons, and they do the job and provide the material flow.